All right, it is Berkeley time, which means we're going to get started on our programming lecture for today. Today, we do kind of have a bit of content to go through for the programming side. I think last week you guys covered how JavaScript can manipulate CSS. And in this lecture, we're going to expand on that a little and kind of expand on the functionality that we can do with JavaScript. So, some announcements. Homework 8 is due like now, and homework 9 will be released later tonight. Lab 8 due next Tuesday as usual. And the final project has already been released. Check Ed if you haven't seen the logistics already. But just know that next Tuesday, along with the lab, you'll have to do your high fidelity OH like mockup check-in, similar to how we did with the midterm. And then the whole final project will be due 2 weeks from then. All right, so just to get into content, kind of revisiting this mental model that we have of how we're going to write JavaScript code. We have this like general framework laid out. And for this lecture, we're just going to focus on this first part, which is like the clicks or hovers over, kind of like the user activity part. So some review from last lecture. Let me move this over. Some review, we have whenever we're grabbing an HTML element, if we're trying to grab it, something that has a certain ID, we can use the get element by ID. And notice we don't have to use the pound sign here because the program already knows that we're looking for an ID, so it would kind of be redundant to do so. So if the ID was menu, let's say, we would just write menu in quotes. And just a conceptual check, what would menu return? Well, not necessarily return, but this variable would then hold or kind of be a reference to the HTML element with the ID of menu. And let's say we wanted to do this with query selector instead. This line of code does the exact same thing. Notice now the presence of the pound sign here. It's just that query selector is a much more versatile function. It can be used to grab elements by ID or by class name. And so, of course, this does the same thing. But of course, we do need to include the pound sign here. And so I've included this slide here as kind of a one-stop shop for the syntax of how we're going to call these functions. So in the case that we want to just select a single HTML element using ID, then we could use either element by ID, omit the pound sign, or query selector and include the pound sign. Let's say we're using the class name. Keep in mind, because ID, there's only one HTML element can have a unique ID. We know that there's only going to be one element associated with it, whereas several elements could share the same class. So whenever you do select by class, keep in mind that your object is not a single element, but a list of elements. So I've kind of indicated that in the comments here, and this is the corresponding syntax. And even if you only have one element with a certain class name, it's still going to be a list, but just a list of length 1. So just keep that in mind moving forward. So menu.classlist. Again, this is still review. What should this return? I think previously we said menu is a DOM element. So this would be a list of menus classes, which then we could add or remove to change the CSS. So in line with that, one example is, let's say we want to add the class dark mode. This is how we might do that. So menu is the object dot class list. Okay, so now we're saying, okay, the list of classes for the menu dot add. So now we're going to call this function on it. We're simply adding dark mode to the list of classes, whether, it might have 1, 2, might have like 10 different classes. Now dark mode is one of those. So whatever we've specified in the CSS to be associated with the dark mode class will now also apply to the menu object. So similarly, if we were to remove a class, we could call remove on it. This is the same syntactical structure. But now if menu has a light mode class, it would just take it off the list. And so any styling associated with that would also be removed. So now moving into our new content for today, kind of revisiting this model. I think you don't actually need to know the specifics of how these different objects are connected. I think the important thing to take away from this visual is that JavaScript views HTML elements in these kind of ordered chunks, each with its own functions and each with its own properties that can be manipulated. And so one of those properties, let's just look at this one, for example, for maybe headers, right? Some of the properties are the list of classes that we saw earlier, the inner HTML, which just references like the text, right? And then the style. This we'll see later can change certain CSS attributes. Okay. And so how we might represent some of the things we saw earlier, get elements by class name. Well, within the body, we might have a bunch of HTML elements with the class of food. And again, the structure is not super important. I think the big takeaway is just know that JavaScript has access to all these things. And this is one way to access it. And again, here we have, if we're grabbing by ID, maybe it views it in this kind of sense. And let's say food list represented an HTML element with the tag UL, short for unordered list. Then JavaScript would now also have access to its children, which is whatever listed items we had within that. So maybe this food list element, sorry, I'm gonna go back. This food list element also had 3 different list items nested within it. So the important thing for today's lecture is the fact that JavaScript is event-driven. What does that mean? Events in this context are any like user actions. So things like clicking the mouse, scrolling, hovering the mouse, maybe like pressing things on the keyboard, which we can represent with these names. These kind of correspond over. So on mouse over would correspond to hovering, on click would be clicking, and then on key down is typing. So we do have ways to represent certain user actions that are associated with JavaScript. And so the big thing here is previously when we wanted to have our web page respond to a user action, like in CSS, we could use maybe the hover pseudo selector, and you hover a certain element and then it changes its style. The only problem with that is it's a little limited in scope because you can only change elements that are directly interacted with by the user. Let's say you want to click a button to change something else. You could not do that previously with CSS. But because JavaScript has access to everything within your HTML page, if you interact with one thing over here, if you write in your code that you want maybe something else to change, you can do that. Because you have access to everything, now there's this interconnection between elements that didn't previously exist. And so let's break this down. So we have 3 parts of this code, right? The first one, these are on separate lines just because we couldn't fit it in the box, but in your code, it would be in one line. So we have this button element that represents some DOM object, essentially whatever HTML element had the ID pop-up button, that's what we're dealing with here, okay? We've also defined some function. This should still be a review up until this point, but we have this function show greeting. So that's the name of our function. And within that, we should just create that pop-up that prints out howdy. Okay, and this last line, this is what's new. We're essentially saying, okay, so for this button element that we previously specified, dot on click is saying, when we click this button, we want to do something. Well, when we click it, we want to call this function. That is essentially what this line is specifying here. And notice we are using this function and we kind of just cap it off without the parentheses. Why is that? Previously, whenever we want to call a function, if let's say it didn't have any parameters like this one doesn't, we'd still have to use those empty parentheses to say, hey, I'm calling this function, do the thing. But because we don't want it to call right away and we want it to respond to the on click, we just omit the parentheses. So just keep that in mind. If you want something to be associated with user action and you don't want it to be called when the web page loads, omit the parentheses. Okay, and also we can do this with other events as well. So it doesn't have to just be on click. We can also do this with the other ones as well. So on mouse over, for this particular example, if you were to hover this button, now it would call the function. Another way we can write this is wrapping our functionality or our code within what we call an anonymous function. So as we saw before, we define the function, and that's its own little block of code that can be called whenever. And then we attach that to the event of onMouseOver. Let's say this button is the only button that will ever call this function. Well, then we can just combine it and make our code a little more concise. And this is how we might write that. So this is essentially the same as this one, but maybe it's just a little easier to read. Okay. So what do we see so far? We can call functions with JavaScript events. Now we can also change the style of HTML elements with JavaScript. Previously, how we did that was we would add certain classes, maybe remove certain classes, but that's kind of taking like a side route because you'd have to change the CSS to then change the HTML. By using this syntax, we're essentially cutting straight to the point. Let's say we want to define this change color function to take in a color. We'll just assume it's a string. And we select this box element here. When we specify dot style, what we're telling the program is we're going to change something about its styling. And dot background color is just the specific attribute that corresponds to the CSS attribute background color. And then we just set it to whatever color we want. So I guess bringing it back, we have this button element, we have this box element, and when the button is clicked, we call this function, which within this function calls the other function change color to red. So the flow of this would kind of be when you click it, it calls this function, which then looks here with red as its parameter, then changes the box to red. So that's essentially the flow there. And forward. And so as we saw here, background color, the way we write it is a little different than in CSS. CSS, we would write background in all lowercase, dash, and then color in all lowercase, whereas in JavaScript now we're saying background and then a capital C. This is known as camel case. You don't have to really know this, but if you ever encounter a case where you want to change a certain attribute and you're not really sure how it's spelled, if it's not like given to you in a drop-down menu in your code editor, you can always just look it up. I think I looked up one earlier today too, and it's just, sometimes that's what you have to do. So what questions do you have of anything we saw so far? Any slides we can revisit? Yeah. So in this case, yeah, if let's say are you saying like maybe put this code and replace this with that? It's just like change color red, but without this? Oh, without function. Okay, so the reason we can't do that is because what that would do is that would call the function right away as soon as the web page loads, because we've shown the parentheses here is telling the program like, oh, execute the function. By wrapping it within this function, we're delaying that so that this function is only called when onClick happens. So like any function is like this way. Yes, there is one other method. It's a little more complicated, but I think for now, just if you have any methods with parameters and you don't want them to be called right away, best practice for now is just to wrap it within the anonymous function. Good question though. Yes. Any other questions? Okay, we can always revisit these slides, but that was the meat of the JavaScript for connecting to connecting to our objects. Now the next part is Boolean expressions. So a Boolean is a type of variable, just like an integer, a float, or a string, but it only carries one of two values, which is true or false. And how this will show up is we will essentially create what we call like conditions, which, so let me reel this back. I'm a little, Sorry. Okay. I guess we'll see that in a later slide. But basically, one other thing that we might see in the flow of our code is conditional statements, which allow you to affect the path of your code or the path that your code takes based on certain conditions. In like layman speak, if X is true, then do Y. That's something we can express within JavaScript. So one thing we have here is the equality operator. Notice we have like 3 equal signs, and this one has like 2 equal signs. The reason we have this, you don't have to know, but just know that this is telling us, this is checking if 2 things are equal, and this is checking if they're not equal. And so we have other relational operators that we've seen before, like greater than, less than, greater than or equal to, and then a helpful table to see for later. And so how might we use the equality operator? If we were to say, let's say 1 plus 1, I'm just going to say equals 2, this would evaluate to true. If we were to say 1 equals 2, that would be false. So don't think of this as an equation. Think of this as a single expression that is either true or false. And of course, 1 plus 1 not equals to 2, that would be true. So there's kind of that double negative going on. We also have logical operators to combine different Boolean expressions to make more like complicated functionality here. We have the and, or, and the not. This is kind of like the one-to-one there. How might we see this? So if we have a true expression and a false expression, that is false. If we have a false and a false, that is still false. Only when both expressions are true does the whole thing evaluate to true. Or is kind of like the flip of that. Only one of the 2 expressions has to be true for the whole thing to be true. So that's what we have here. And also not is just whatever it is, just flip it. So not true would turn into false, not false turns back into true. So let's kind of take a look at this. Parentheses kind of separate just as they would in math, and you can have as many parentheses as you want. It doesn't really change the value. Let's try to break this down. So 1 plus 1 plus 2 equals 3. This one should be true, right? 5 times 6 equals 31. That one should be false. Okay. So now let's kind of simplify in these small, like compartmentalized steps. We have true and not false. So not false, that should just flip and turn into true. Now we have true and true. This together just returns true. So that's how we might evaluate a complex expression like this. And lastly, we have conditional statements. So how does this tie into JavaScript? Essentially, conditional statements allow you to kind of diverge into one or another path based on the presence of a condition or not. So the simplest structure is just if, and then within parentheses, a condition. And then these curly braces kind of denote like a block of code. Within that, then you would write your code. So if this condition is true, then you're going to execute whatever code is within there. So in a function, let's say we have these 2 if statements. We take in a number, right? And the first if statement checks, is the number equal to 5? If it is, then you're going to execute this code. Cool. And if it's not, then you just skip over it. We see the next one. If the number is greater than 4, then you're going to execute this code. And if not, then you just skip over. So let's just quickly think, what would passing in 6 do? Anyone have any guess what we might print out? Yeah. Yes, exactly. So just to check the flow of that, we would first check, does our number equal 5? No, so we just skip over it. And then it is indeed greater than 4. So then we would print this out. If we were to do numbers equal to 5, anyone know what that might print out? Go ahead. Yeah, it would do both, right? Because these if statements are like separate, if both are true, then both will execute because they're just separate blocks of code. And once we get down to 4, we would see, okay, this one doesn't work, so that skips over, and then 4 is not greater than 4, so we would also skip over. Cool. Now, what if we introduce the else statement? So now you can think of these 2 conditions or these 2 statements as connected. if this thing is true, do this code. Otherwise, do this code. So it's very similar to English. If this, do that. Else, do this. And so now number equal, and we pass a number. If we can kind of run through this functionality, would essentially tell us whether or not our number equals 5. But maybe we also want to add more conditions rather than just if this, do this, otherwise do that. Maybe we want more paths. We can specify as many as we want of else if. It just has to be placed between our if and else. So you can have only one if statement combined with as many else if statements combined with only one else statement. And so if we were to run this code, this one is a little more to go through, but anyone want to take a stab at what number equal 6 does? What will this one do? It's a little different than what we saw before, because once it enters one of these statements, it ignores the rest that are connected to it. So at most, calling this function will only print out one line. So what line would that be if it were 6? Cool. Anyone want to put, I guess? Yes, you. There you go. Go ahead. What would number equal 6 do? Oh. Okay. Well, let's do it together then. So it would check this condition. Is 6 equal to 5? No. Let's move on. Is 6 greater than 4? Okay, it is. So then it would enter whatever this statement contains. It would print number is greater than 4, and then it would just completely exit. And so 6, 5, 4, they would all do the same thing. It would just check until one of them evaluates to true. We can now think of else as this kind of catch-all net, where if it didn't meet any of the conditions before, it's going to enter the else statement. And so one thing this might be useful for is expressing ranges without having to hard code values for every single possible case. Let's say we wanted to, I don't know, do something, right? And we want to check the ranges between 10 and 20, and then everything else would just like print whatever. Pretty much, this would catch all numbers greater than 20 and then tell you that it's greater than 20. If it's not greater than 20, let's check. Is it less than 10? If so, then number is less than 10. And then this else. This else catches everything that's not greater than 20 and not less than 10. So essentially, everything between 10 and 20. So this is one way we can apply this chain of if and else statements to express ranges. And one thing is, now that we know that we can use an infinite number of else if statements, don't get carried away and just like blindly do that. There's definitely a time and place for multiple else if statements. But in general, we want to keep our code concise and not have something like this. And maybe we can shorten it to something like this. And just really quickly introducing a new operator. This % is just known as modulus, which calculates the remainder after division. So if we had like 5 modulus 2, we can think of that as like 2 remainder 1. And so this code basically checks if the number is even, just for future reference, if you're curious. I think that's the end. Yeah, so that's the end. So do you have any questions on anything we saw so far, anything we want to revisit? Okay. If not, then we will pass it on to Kylie here. Okay. Thank you, Kathleen. Pass it